All right. Let's see. Let's go here. Let's see if there are any other people I can get right now. This one. Let's see, that person's not on my roster. Oh, there he is. E, F, G. This thing is out of order. It's weird. Oh, he has a different name. That's right. There we go. Cool. All right. Let me share my screen. And anybody that comes in after this point, they're gonna have to get in at the 15-minute mark. You know, sometimes I'm late to that time, but oftentimes I'm late to that time. But you know, yeah. Okay. No major announcements. Hope everyone had a great weekend, right? You were able to get some rest and get some work done. We are at the top of week 7. So what that means is that exam 2 will become available this upcoming Sunday. I think I scheduled it for 11 a.m. It'll be available for 7 days, and it'll be due the following Sunday at 11:59 p.m. So I'll do the best I can to try to wait until that due date before I calculate midterm grades. All right, midterm grades is basically, I want it to be based on all the material corresponding to exams 1 and 2. Basically, usually what I do is the homework counts for 10%. Whatever your homework average is, I'm gonna scale it so that it's 10% of your overall grade. Whatever your quiz average is, I'm gonna scale it to 10% of your overall grade, and then we'll have 2 exams that those 2 will count as 80%. The midterm, the midterm on your transcript or on Bannerweb, all it is, it's just a snapshot of where we are at that moment, right? It has no bearing on your final grade. So, you know, if your grade is low at the midterm, it's just an alert like, hey, you need to do something different to bring this grade up. If your grade is where you wanted to be by the midterm, then now it's like, okay, now you're trying to play the game of maintaining. You figured something out. Now you want to try to keep going what you got going. As always, you know, this is remote asynchronous. You're not obligated to stay. If you have questions, feel free to unmute yourself to get my attention. If you've emailed me, best thing is just to ask me during class. I mean, I may or may not check those emails. I'm just not good about checking them. I'll be living my life when I'm not with you guys. I mean, not that you're not part of my life, but yeah, I don't even think about it until it's time for class. So, but I do encourage you to email me anyway, just to have it on record, because I do dig through my emails and search for different things. So, you know, I use it for record keeping, but the best way to communicate me is just via live. Since I don't have an office, I don't have an office phone. You know, this is why I set everything up the way I did, so that we can have time in class to you know, go on the fly as needed. All right. I think so. Today, let's see what we're working on. I think we're going to be closing out chapter 3 with section 3.4, exponential and logarithmic equations and inequalities. One other thing as far as announcements go, I want to say this upcoming Monday and Tuesday is fall break. I think October. I think it's this upcoming Monday and Tuesday. I got to confirm those dates. I'll probably send an announcement, but we're not going to meet. If it's fall break, then we're not going to meet for that time period. I can't think of anything else, right? So again, if you have questions, comments, or concerns, feel free to either unmute yourself to get my attention. That's the recommendation. Or if it needs to be more private, feel free to put it in the chat. And I check the chat periodically, right? Sounds like a tongue twister. Check the chat. But anyway, okay. So like we said a moment ago, we're wrapping up chapter 3. So I think I made exam 2 it's essentially chapter 3, right? It may or may not include 3.1, but again, you can't do 3.2, 3.3, and 3.4 without using material from 3.1, right? So kind of by default, math exams are generally by default cumulative, right? You can't do stuff in section 3.4 without using material from 3.1, right? So whether I exclusively have questions from 3.1 or not is a moot point. I could ask questions strictly from 3.4, and that covers pretty much all of chapter 3. Right, so that's the long and short of all of that. Long story short, exam 2 is essentially should be focused on chapter 3. Okay. All right. So then today we want to conclude the discussion on exponential and logarithmic equations with by exploring exponential and logarithmic equations and inequalities. A few objectives that we have: we like to solve exponential equations. We like to solve applied problems involving exponential equations. We like to solve logarithmic equations. We like to use a logistic growth model and use logarithmic and exponential inequalities. Okay. So here we're asked to solve each equation. I think I got enough space, so we're going to work with this. And let's see. Okay. So something like this, for part A, what I will personally do is try to get the left and right side of the equal sign, try to get them to have the same base, as an exponent with the same base, all right? So let me get a copy of the original. We got this 25 to the power of x equals 125. Now 25, we can write it as an exponential with base 5. We can rewrite it as 5 squared, right? So we're going to have 5 squared to the power of x. And on the right, we can also write that 125 with the base 5. So 125 is going to be 5 to the power of 3, right? So then here, when we have one power raised to another power, we multiply. Like baby's kids, we don't die, we multiply, right? So a power to another power, we multiply those guys. So then if we continue, we can rewrite that as 5 to the power of 2x equals 5 cubed. Now that we have two exponential expressions with the same base, now we can, one of the properties that we have for exponents in this form, now we can just equate the exponents. So we can say 2x equals 3, divide both sides by 2, x equals 2/3. Okay, hopefully that made sense. Okay. All right, so let's see if we can do something similar for part B. So let's start by getting a copy of the original. We have this 9 to the power of x equals 3 to the power of x plus 1. Okay, so maybe we can get these to have the same base again. So we can rewrite the 9 with what? Base 3. So 9 is what? 3 squared to the power of x. 3 to the power of x plus 1. Okay. So again, those powers we multiply. So that's going to be, somebody have a question? Let's do like this. Oh, let me get these guys. Okay. Let's just do like this. Do you have a question, Mr. Neal? Mute him. And what time is it? It's a little bit early. Okay. I'll check it again in a few minutes. This is ABCD. Cool. All right, and I'll check it again in a little bit, just in case somebody else is. Oh, and let's do like this. Screen, start the broadcast. We left off here. Okay. Oh, it's 111, angel number. Okay. So we essentially, got to the same point. Now we're at 3 to the power of 2x equals 3 to the power of x plus 1. So then we can just equate the exponent. So then we'll get 2x equals x plus 1. Subtract x on both sides, x equals 1. All right. Now, before we move away from these examples, with something like this, we can actually check, right? We can check and confirm. So what I'm going to do is do my best to break out my trusty dusty rusty. Yes, awesome. Okay, do I need to reload it? Cool. Reload and refresh. God is good. Okay. And let's do it. Let's go like this. Come on, like that. Okay. What's single page right now? Okay, yeah, I forgot about the single page technique. Okay. All right. So let's confirm this. So for instance, if we do, let me do it like this. For part A, I'm going to go to my y equals. Let me think. Okay, I'm going to do this a little bit different. So I'm gonna go to my y equals, right? For part A, we have 25 to the power of x, right? For part B, there are two parts. So I'm gonna do it in the following way. I'm gonna say 9 to the power of x, and then I'm gonna go down to the third one. I'm gonna say 3 to the power of open parentheses x plus 1, right? So that way, we need the parentheses there so that way we know that that plus 1 is in the exponent and not off to the side, right? So all the parts, I put them in 3 different equations, all right? So then I'm going to quit. And I'm first for part A, I'm going to call in that first equation. So on the right-hand side of the calculator, there's a button that says clear. To the left of that is a button that says VARS. I think it's short for variables. I'm going to click on that. I'm going to go to the right to go to Y variables. I'm going to click on number 1 for function and number 1 again to call on that function, right? I'm calling on part A. That's basically the 25 to the power of x. I'm going to do open parentheses. And now our claim is that when x is 2/3, the output should be 125. So I'm going to do 2 divided by 3, close parentheses, and hit enter. Let me see. Oh, not 2/3, 3/2, right? So that was wrong. So we basically just need to, it's 3 divided by 2, so that should be 3 over 2, not 2 over 3, right? That's why we check, though. That's that ability to check is what made me fall in love with math, right? Because we can check our work. When I was a student, not that I'm still a student, but when I would get on an exam, I would get an answer. I would ask myself, okay, does this answer make sense? What does it mean for this to be the answer? Well, you're saying that when you plug it into the original, the output should be 125, right? So we saw where we plugged in the 2/3 and it didn't match. I was like, wait a minute, we made a mistake. So then we had to go back and find where we made our error. Chance favors the prepared mind, right? So like with math now, it's a little bit different because obviously we're not in a testing environment, but that doesn't mean that you won't be in the testing environment again, right? At some point. So if you ever find yourself in a testing environment, then you want to check your work before you submit it, right? If you submit something in a testing environment and you get a result, you get an answer, you did all this work, you've been in school for at least 12 odd years, you've done all this stuff, you got to this answer, and then you're going to submit it, you'll be like, it may or may not be right, I'm going to leave it a chance. But again, chance favors the prepared mind, right? So if you submit your work without checking, it's basically like saying, I did all this studying for all these years, all this work, and I'm gonna just leave it up to chance. But when you check it, now you drastically boost the odds of success in your favor, right? So it was because of experiences like that is why I fell in love with mathematics. Okay, so now let's check part B. Our claim for part B is that, when x is 1, it makes the left-hand side equal to the right-hand side, right? So I'm going to call on the second equation because that's where we put it. I'm repeating that process, but instead of choosing y1, I'm going to choose y2. And that x value is 1. I think we get an output of 9, right? And then I'm going to call on y3 because that was the second part. And again, when x is 1, it should still be 9. Let's see. Let's go to y9. Okay. Variables. I clicked on the wrong thing. Clear. Let's go to variables, function, and I need to click on 3. I don't know what I clicked on. But again, when the answer is 1, output is 9. All right. Let me just recall the other one again so we can at least have it on the screen. Not that one. This one. All right. So notice when we plugged it in on the left and the right, in either case, the output was the same. So then this value of x makes the left-hand side equal to the right-hand side. Okay, hopefully that made sense. Let me let me check Zoom one more time, just to kind of see if we got any scragglers. Let me stop sharing my screen, and I'll check the chat in just a moment. This student, there he is. Okay. This one, let him in. Attendance is pretty good. I'm proud of you guys. Like, for the most part, we're still missing a few people, but to have so many people in the class, like, I don't know, this works for me. Like, you know, this is just easier for me. This whole remote thing is easier for me. And I can assure you it's okay, no worries. You know, as long as you're here, you know, we know that you're breathing, you're kicking, you're alive, you're good and well, happy, healthy, wealthy, you know, these kind of things, then it's all good. Okay, so let's get back into it. All right. So we got these results. We did have an error, but we caught it because we checked it. So then now we can stand in confidence, right, with these results. So we got 3 halves and 1, and then here's a type version of what we did. 3 halves and 1. Okay. Here's another example. We're actually just basically solve for x. Okay. So let's start with. Let me see something. It's okay. Let's start with a copy of the original. So we're starting with 5 times 2 to the power of x minus 3 equals 17. Okay. Let's see. So this one, it doesn't look like we can get the left-hand side and the right-hand side to be exponents with the same base. So we might have to do something a little different here. We basically want to move things away from the x. We might have to use our calculator to get a final result. All right. So if we're moving things away from the x, starting from the furthest thing away and moving towards the x, the furthest thing away to move is going to be this 5. All right. So in order to move the 5 to the other side, we do the inverse operation. The inverse operation of multiplication is going to be division. All right. So first we want to divide both sides by 5. A number divided by itself becomes 1. So on the left-hand side of the equal sign, we're left with 2 to the power of x minus 3. And on the right, we still have this 17 by 5. Okay. So now in order to move the x out of the exponent, the inverse operation of exponential is log. All right. We're going to take the natural log on both sides. So when you want to pull something out of the exponent, because logs and exponentials are inverses of each other, we take the natural log on both sides. Okay. And what this does, this allows us to move this out of the exponent. Okay. So then now at this stage, we have x minus 3 times the natural log of 2 equals the natural log of this guy. Okay. So then if we divide both sides by, so now this natural log of 2 is just some number. It's some irrational number, but it's a number, right? So we're saying this binomial times this number, we want to move this number to the other side. So the inverse operation of multiplication is division. All right, so we're going to divide both sides by natural log of 2. Okay, a number divided by itself is 1. And let's continue over here. So now at this stage, we have x minus 3. And I'm just keeping it exact until the very end, right? Natural log of 17 by 5 divided by the natural log of 2. Okay. Keep in mind the number. This is just some number. This is just some number. This is some number. Again, we're keeping it as exact until the very end. And then now we get x equals natural log 17 by 5 divided by the natural log of 2 plus 3. That's the exact result. Then at this point, we'll use a calculator to get a decimal approximation. Okay. So then we have the natural log of 17 by 5 divided by the natural log of 2 plus 3. Okay. And then I'm just going to round it to 3 decimal places. So then x is approximately 4. Why is it behaving like that? 4.765. So for 3 decimal places, it would be 766. Okay. And on top of that, I think we can check this. Yes, we can check this before we submit it, right? So I'm going to kind of redo the way the previous, right? I'm going to clear these out and kind of do it in a similar fashion. Okay, we round it. That's going to kind of throw things off. All right, so I'm going to put 5 times 2 to the power of x minus 3. Okay. The output should be 17, so I'm going to quit. I want to call on that answer I just got, right? So that's what we just used. So then what I'm going to do, I'm going to call the function that I just put in. Okay. Parentheses. Now, instead of writing, if I use that rounded result, I'm going to get something close to 17. I'm going to just call that answer. So I'm going to hit second negative. And basically I'm saying take that long decimal and pass it through the function. We should get at least either exactly 17 or something really close to 17. All right. We got exactly. All right. So again, I took, instead of, because if I had put 4.766, because that's rounded, it's going to give us something that's close. 4.766 is going to give us something close to 17. All right. Okay. So that was fun. Like this, move this out of the way. So that was just us rounding to 3 decimal places. And then here's a type version of what we experienced. Let me see. So yeah, they went on divided both sides by 5. They got 3.4. Then they took the natural log on both sides. All right. So then you get basically what you see on line 2. And then, it kind of follows. Let me see something. Okay. So no, x minus 3, right? Where's that 3 coming from? It should be x minus 3. Oh, did they distribute that natural log of 2? No. I think that might be a typo. I think that's a typo. That extra 3 on the left. I think this guy's a typo. Because you can see on line 4 they divided both sides by log of 2. Let me see. I think I can edit it actually. Like this. I'll do copy and paste. Oops. I think that's a typo. Check one more time. Because when you take the natural log of 2, the x minus 3 comes out of the exponent, comes down, right? That looks better. Divide both sides by the natural log of 2, and then add 3, 4.766. Okay. Copy. All right, so, again, as usual, if anything is not clear, if I need to go back, just feel free to unmute yourself to get my attention. Let me check Zoom really quickly to see how you guys are doing there. The chat looks clear. Okay, we got some people standing strong. We got a few hanging in there. I know this stuff drones. I get it. I mean, I experienced the same thing. It's tough. It's I can imagine if you're not math and orientation, this stuff is just like, mind numbing, right? And so you have to I mean, you know, I don't expect you guys to be mathematicians. I don't really intend to dive into all of that. Let's take a look at this one. So we're asked to solve the equation and approximate the answer to 3 decimal places, right? So it's kind of the same thing. Let's try another one. So we got this 5 to the power of 2x minus 3. And that equals 3 to the power of x plus 1. Okay. So we can't get the same base, but we can take the natural log on both sides. So then we can say the natural log of this left-hand thing, and what we do on one side, we do it on the other, right, for balance. So what this allows us to do is to bring these guys out of the exponent and in front of the log, okay? So at this stage, we have 2x minus 3 times the natural log of 5 equals x plus 1 times the natural log of 3. Okay. Keep in mind that natural log of 5 and natural log of 3 are just numbers. Okay. Now let's expand this guy. Let's distribute this number like that, and let's distribute this number like that. Okay. So then if we do this, let's see, we're going to get 2 natural log of 5 times x minus 3 natural log of 5 equals, let me see. Wait a minute. Let me write it like this, because I want to be clear that the x is not inside the log. All right. So when we distribute that natural log of 3 over here, I guess just to be consistent, it's going to be the natural log of 3 times x plus the natural log of 3. Right. So now 2 of our terms have variables and 2 of them are just numbers, right? So let's group the terms that have an x side by side, and let's group the constants together. So essentially what I want to do, let's move on the right-hand side, let's move that natural log of 3 times x, let's move it to the left. And that 3 natural log of 5, let's move that to the right. So we're going to use inverse operations. Since that natural log of 3x is positive, we're going to subtract natural log of 3x on both sides. Right. I probably should put the x in front of the log so that we can be clear that that's not inside the log. But this is fine for now. And then, so again, these guys are going to add to 0. And I'm going to also go ahead and say 3 natural log of 5. Add that to both sides. Okay. So then, if we account for those changes, this adds to 0. Now on the left, I'm going to, it's fine. So on the left, we have 2 natural log of 5 times x minus the natural log of 3 times x. And on the right, we have 3 natural log of 5 plus the natural log of 3. Okay. So each term on the left, they both have x. The terms on the right are both constants. Okay, I'm going to continue over here. So then on the left, that means we can factor out, they both have an x that we can factor out on the left, right? So now on the left, we're going to have 2 natural log of 5 minus natural log of 3. Again, there's the x that we factored out. And then the right, I'm just going to leave it as is. 3 natural log of 5 plus the natural log of 3. And I'm running out of space. Okay, one more step. I know it's a little intense, but we're pretty much there. So now we have some number times x equals some other number. So then to solve for x, we divide both sides by this number here on the left. Right? The inverse operation of multiplication is division. So then ultimately we get x equals, it's going to be 3 natural log of 5 plus the natural log of 3 divided by 2 natural log of 5 minus the natural log of 3. That's the exact result. And then we will use a calculator to approximate that. Okay, x is approximately. So then in my calculator, I'm going to do open parentheses. I'm going to group the numerator, and then I'm going to say close parentheses divided by the denominator group together, right? So if we start working on the numerator, I'm going to say 3 times the natural log of 5 plus the natural log of 3. I'm going to close off my numerator and then say divided by 2 natural log of 5 minus the natural log, where is it? Natural log of 3. Close off my denominator. Okay, so that's the exact result. And then, and again, with these, especially when you're working in Pearson, you want to do your best to not round it to the end. You want to try to keep it as exact as possible. And like, so the way I've been doing it, where I haven't been crunching any numbers, that's keeping it exact until the end. If you want to crunch those numbers early, as you do your calculations, you in order to not round, what you want to do, if you're going to crunch the number early, you got to write out the long decimal. So whatever the long decimal that you get, you want to keep writing that out until you get to the end. Once you get to the end, then you could truncate it, and that usually works too. But if you start cutting it off early, like if you start rounding early, it's going to throw off the final answer. So the goal is to keep it as exact as possible until the very end, either by doing it the way that I've done it, or if you crunch the numbers early, you want to write out the long decimal. Keep writing out the long decimal each time until you get to the end. Okay. So then here we get 795. After the 5 is a 3. The 3 tells us to round down to 5, so or stay at 5. So then 795. Okay. I know that one, I can see you guys' face. Like, I just remember like being, in front of the students and like, okay, you can just see the eyes gloss over and like, you know how that goes. And so like even right now, I can't see that face, but I can imagine, I can acknowledge that, trying to follow somebody else doing this, it can be a little bit mind-numbing, a lot of it mind-numbing. Now, the recommendation is, as you watch these presentations, don't try to follow every detail. Just try to pick up on like the gist of it, right? Just pick up on like tips and tricks. And it's not until you try it yourself where it comes out, right? This is kind of like that thing where the truth can't be told, only realized, all right? So I'm showing you that it's possible to get through this stuff, and then you want to take these presentations and then see if you can do it yourself. You got to keep trying until you're able to do it, okay? 2.795. Okay, and I think they essentially did verbatim everything that we did. Okay, let me check Zoom for a moment. Okay, I think we got some latecomers. So one. Okay, I get them. Ouch. Okay. Got him, coach. Man, thank you. We got about 10 minutes. Let me see. So let me go back to sharing my screen. Start the broadcast. That looks healthy. Okay. All right. So, so this is when different bases are involved, begin with step 2, right? Okay. So let's see what else we got. So we made it through about 10 slides, another equation. So let's have at it. Let's give it a go, right? Because each one, you don't really know until you try, right? So let's give it a go. Trying to think if I need more space. I don't think I'm gonna need more space here. So if we start with a copy of the original, we have 3 to the power of x minus 8 times 3 to the power of negative x. The final result should be 2. Okay, let me think here. Now, negative exponent moves it to the denominator. So I'm just going to rewrite this guy. So then we get 3 minus, that negative exponent is going to be the same as 8 over 3 to the power of x equals 2. Okay, so I'm a fan of clearing out my fractions, right? If I want to get that 3 to the power of x, if I want to remove it from the denominator, I want to multiply the left side of the equation and the right side of the equation by the LCD, the least common denominator. There's only one denominator. So in this case, the LCD is the 3 to the power of x. So what I'm going to do is multiply the entire left-hand side by 3 to the power of x, and the entire right-hand side I'm multiplying by 3 to the power of x. On the left, I'm going to distribute that guy. All right. Okay. Let's see if this helps us at all. Okay. I hope there might be a more simple way to go about this, but I'm just going to kind of keep going because this is just what I'm seeing. So now on the left, 3 to the power of x times 3 to the power of x. So with those when you're multiplying exponentials of the same base, we add the exponents, right? So this guy times this guy, we add the exponents. So x plus x is going to give us 2x, all right? Let me think about that. Okay, let's go with it. Hopefully I'm not making a mistake. Let's go with it. Okay. So x plus x, so let's see, it should be 3 to the power of 2x. When we multiply the blue times the second term, they're going to cancel. So we're going to be left with minus 8. On the right-hand side, we're going to leave it as 2 times 3 to the power of x, okay? So what I want to do, I'm going to make this 0, and I'm going to change the form just a little bit. Now, 3 to the power, yes, right? 3 to the power of 2x, we can rewrite that in a way that's going to help us. I'm going to rewrite it in the following way. So I'm going to set it to 0 and rewrite the first thing. Now that 3 to the 2x, I want to write it like this. 3 to the power of x squared, right? 3 to the 2x is the same as 3 to the power of x squared, right? Because a power to a power, you multiply. If I subtract that 2 times 3 dx, I'm going to subtract that on both sides. So we're going to have minus 2 times 3 to the x. Okay, and I'm going to go like this. Maybe that might help us. And then the minus 8 just comes down. And now we've essentially set it equal to 0. Okay. So now the technique that I want to use is a technique called U substitution. So notice we have something squared minus 2 times something minus a constant. So let's replace that something with U, right? This is called U. This is a technique that's called U substitution. So we're going to say, let U equal 3 to the power of x. Okay. If we do this, the following happens. We're going to have what? U squared. Okay. We're going to have this. U squared minus 2 times U minus 8 equals 0, right? So again, after applying, and again, this technique is called U substitution. That's the technique that I used here. All right, it's not obvious. You wouldn't know this without coming across it in your journey, right? Either somebody would have to like point it out to you. It's not normal to think that way, right? But that's the trick here, right? That's the technique. So now in this form, right? In this form, now it's just like it's a quadratic, and you know how to solve this, right? So maybe we can factor. Looks like we might be able to factor it into some form like this. Then we have our U and U still equal to 0. Two numbers that multiply to give us -8 and add to give us -2. -4 and 2. -4 plus 2, right? This times this gives us -8. This plus this gives us -2, okay? So then zero factor property. So then from here we get that U equals, so we get what? U equals 4 or U equals -2. So then we need to put it back, right? So we got it, we broke it all the way down to here. And now we need to do that substitution back. We need to put it back, right? So this means 3 to the power of x equals 4 or 3 to the power, that's not an x. or 3 to the power of x equals -2. Exponentials, right? The range for exponentials, you can't do a negative. So we can already scrap. That can't happen, right? Because if you think about the graph of an exponential, the graph of an exponential is entirely above the x-axis. So, it's not going to get, we're not going to be able to find the x to make y negative. So we can scrap that one. So then from the guy on the left, basically we take the natural log on both sides. I guess let me show that. I know we're just about out of time, I think. Let me check the clock. Yeah. So if we take the natural log on both sides, we're going to say the log here and the log here. Okay. So then, because I'm running out of space, I'm just kind of jump a little bit. You're going to get x. So then ultimately you get x equals the natural log of 4 divided by the natural log of 3. Okay. That's the exact result. And then if I use my calculator, I can crunch that number. Okay. Again, that was a journey. Because of stuff like this is why I set up everything the way I did, because after being a person, engaging students in the past, that glossy-eyed look in their eyes, like, with their mind numbs over. Because again, you guys aren't mathematicians, you are geniuses, but you don't expect everybody to sit down and have to go through all of this. 3 decimal places is 2, so 262, 1.262, right? I don't know. I guess I resonated more with like numbers than people. It's kind of weird, like, because I can just kind of sit and think about it, and it's fun. It's fun when you figure it out. When you don't figure it out, then it's frustrating, and it just keeps like nagging until you figure it out. Okay, all right. I'm just going to go ahead and check that because we're short on time. Okay, we got that result. So what I'm going to do is I'm going to go to my y equals, and I'm going to do 3 to the power of x minus 8 times 3 to the power of negative x. Okay. I think we did that. Okay, let's quit. So then I'm going to go to variables. I want to call on that function I just typed in. And I want my x to be that answer. Okay. The output should be 2. Okay. So we checked it. We got it to work. That's about the best that we can do with something. And if we compare this to the prepared notes, this isn't even halfway through this section, right? So solve the equation. Let's see. They multiplied both sides. I think we did something similar, right? 3 to the power of x to LCD. And then you see they got to the same line at 3 to the 2x. This equation is in quadratic form. So instead of y, we called ours u, but it's the same technique. So let y be 3 to the power of x. So then, right? And then basically it's u substitution, right? So they rewrote it, solved. Okay. So then again, 3 to the x, but 3 to the x equals -2 is not possible because 3 to the x is strictly positive for all numbers x. So then we only solve for 3 to the x equals 4 and then 1.262. Okay. All right. So I feel like there should be questions, but again, my experience, come on. You guys in there? It's kind of frozen. Let me see if this works. Let me stop sharing the screen. Yes, no worries. Okay. If there aren't any burning questions, so let me see. Let me go ahead and, hang on. Okay, that's where we left off. And I tried to add a page. Okay, that's okay. Let me try it again. That's where it froze. I guess it doesn't matter because we're not sharing the screen. But let me go ahead and make a copy of this available for you guys. So fall, this is College Algebra 2, right here into the notes. Updated daily, right there. 2, 3, 4 was the exam. Okay, send the box. Okay. So all the stuff that you saw me writing, I'm making a PDF available, a copy of the PDF available for you all. Basically, you go to our Blackboard page and you can find it there. If there aren't any burning questions, we're going to end the session here. Okay, from one beautiful mind to another. Take care. See you in a couple of days, same time, same place. Peace. So there was a question about, someone says, do we have a midterm? It's just exam 2, and exam 2 should become available this upcoming Sunday at 11:11 a.m. And it'll be due the following Sunday at 11:59 p.m. So I'm trying to wait until it's due before I calculate everybody's midterm grades. We kind of talked about the midterm in the opening, so it's probably best to just watch the recording so you can go back and see what the announcements were as far as that's concerned. Because I don't want to forget something or anything like that. But yeah. All right, guys. So take care. I'll see you on Wednesday.